Hi, my name is Nis Thamang and this is my assignment 3 video demonstration for advanced topic in software engineering. For the assignment, I select the cinema seating as my chosen business context and develop a seat booking optimization algorithm that prevents the isolated single seats from appearing in the seating plan. Before writing any code, I plan my algorithm logics on a paper first. My algorithm sorts the row in a priority order, starting from the middle C, D, and E first because they offer the best viewing experience and are the most desirable seat in the cinema. For each row, it looks for a continuous block of seats equal to the group size requested by the customers. Before confirming any booking, the algorithm checks the both sides of the blocks. For example, if I look at this row, if placing the groups here will leave just one single seat alone on the either side. The algorithm rejects the positions and moves to the next one. This continues until a safe position is found or all the rows has been adjusted. Special cases are handled separately. These gray scales with X marks are broken the seats. They are treated as a permanent walls and completely skipped by the algorithm. These orange seats in the row G are accessible seats, reserved exclusively for the customer who need the accessible seating. And finally, the admin override the buttons, bypass all the rules completely when needed. Let me start with completely empty cinema. I will select a group of 4 people and click the book seats. As you can see, the algorithm immediately placed in the group in row C the highest priority middle row. The seats have turned to the red, confirming that the booking and no isolated gap has been created on either side. Now, let me book the some several groups to show how the algorithm fill the seats progressively without creating the gaps. Now, I will book the group of 3. Now, a group of 2, and now a group of 5. Notice how each booking averages the living single isolated seats behind the algorithms carefully choosing the best available position every time while protecting the remaining seats from becoming the isolated and wasted. Now I will actively stress the test. We simulate a busy Friday evening with approximately 70% of the seat already booked. The cinema is now heavily occupied. You can see that the seats are taken across the multiple rows with limited available remaining. This is where the algorithm faces its biggest challenge. Let me try the booking of the group of 3. The algorithm sources all the rows carefully and still find a valid position that averages the creating the isolated group. Let me try with the group of 4. And again, let me try. The cinema is still getting the very full now. Let me keep trying. And here, the algorithm honestly reports that there is no suitable seat can be found without creating the isolated gap. Rather than forcing a bad placement, the systems correctly notify the user that no suitable seats are applied. Let me reset and demonstrate accessibility setting. I will enable the accessibility mode and select a group of 2. The algorithm restricts its sources to the orange accessibility seed in the row G, completely ignoring all the rows. Regularly, the customer are never placed in these seats under the normal booking condition. Finally, let me demonstrate the admin's override features. I will actively stress the test first to fill the cinema to 70%. Now, I will click the admin off and the button to activate the admin mode. Notice that the purple banners at the top confirming that the admin mode is now active and all the normal seats rules are bypassed. I will now try to book a group of the 3 in admin mode. The system successfully placed the groups anywhere available regarding the isolated gaps rules. This confirmed that the message is clearly. This was the admin override booking. This module taught me a lot about the plan-driven development and how to design the algorithm that handles the real-world programs The most challenging part was designing the isolated prevention logic while keeping the algorithm efficient in nearly fully scenarios. Dr. Kane modules was very important, was very supportive and well organized. The assessment brief and explanation made the task clearly, and guidance provides helped me complete the work confidently. In this assignment, I have learned how to develop and implement a setting optimization algorithm from scratch, and applying the modules to document the systems and build a working React prototype that demonstrates the algorithm under realistic conditions. Thank you for watching.